Okay, hey, I'm Derek Weeks. I have some data to share with you, and I'm really excited about it. How many of you were here last year when I presented the State of the Software Supply Chain Report, the first one? Okay, so it is not the same presentation. It is, we have new data. Hooray! Okay, so this year I was, this is loud. I'm normally loud, but this is... Oh, yes. Okay. More Derek. Okay, so let's entertain you. So in the application economy, we all know that he who builds the best application wins. And if you're going to build an application, you should build it really fast. Because if you're not building it fast, someone else is, and they're getting to market before you, and they're winning. Oh, but fast means you actually need to worry about things like quality and security, and a few people here wonder about security along the way. So we're not writing software from scratch anymore. In fact, we are manufacturing our software. And we are doing this because it makes us, as developers, how many are developers in the room? Right? You write code good. How many are security people? How many are both? Okay, great. Okay, so you know that you're using, and others that you know, if you're not using it, they are using open source and third-party components to build their applications. And the average application now is about 80 or 90% composed, or the footprint is 80 or 90% open source components. Whether these are Java, NPM, Ruby gems, PyPy packages, what have you. Right? So the interesting thing about these components, and some of you know this from attending last year's session, or if you've read the report, is not all parts are created equal. Right? So there are different versions of parts that are out there. You have, I think we counted something like 67,000 instances of jQuery that are out there, and some are very different. Some are slightly different. Some are newer versions. Some are older versions. Some of these components have known security vulnerabilities. Some have security vulnerabilities yet to be discovered. Some have different licenses, but they are not created equal in terms of the software. So I think it was James Wickett. If not, it's the wrong attribution. But we were talking about this, and he said, the theme of kind of what you guys are doing is making invisible things visible. And that really kind of drove the theme of the report this year, that we at Sonatype, where I work, can see things that other firms cannot easily see, because we run something called the Maven Central, the central repository. It's the largest home of open source components for Java development in the world, and that's part of what I based my research on this year that I'm going to share with you on what's happening in development. So there's an organization that I work with, and I just want to help paint the picture of what's going on around there so that you can understand why it is so pertinent that we pay attention to this issue. When we all know using known vulnerabilities and open source components is in the OWASP top 10, is the A9, right? Why is that? We're going to walk through, you're going to know very explicitly why this is in the top 10. So there's an organization in the United States that I've been working with over the last couple of years, and that organization last year, it's in the healthcare field, consumed 16 million open source components from Maven Central. They have about 2,000 Java developers that they employ. They downloaded 16 million components last year. Now, a little more detail that we have about what they're doing. Of these components, how many were unique? About 5,000. If you strip out all the versions of those components that they downloaded, if you just look at, if I just wanted the best version of every one of those components, how many would I need? Guess. 200? 2,000. I need 2,000 components to do software development across 2,000 developers, right? If I chose the best one, but I'm downloading those 16 million times, right? And as I'm freely downloading those and bringing them into my organization, some of them have known security vulnerabilities. Anyone want to guess how many of the 16 million had a known vulnerability? Okay, 67%. There's always a pessimist in the room, right? 773,000 components had a known vulnerability day one of download, right? Now, let's walk through more of the numbers. So the numbers are important partly because why are you downloading 16 million components? You're a developer, right? You have a deadline, right? Do you want to code from scratch, or do you just want to pull something from the internet that already does that so you can meet your deadline, get done with your day, make your boss happy, go home, have pizza with your kids, right? You want the gains in efficiency that that provides. And yes, you may download the part more than one time throughout the year. And yes, you may use more than one version, but this is efficiency. This is time to market. He who builds the best software wins, right? So there are trade-offs, though, within that. And that's some of what we're going to see in this year's report. So this year, I took a look at 3,000 top-performing software development organizations consuming open source components across the world. And we also did a deeper dive into 25,000 applications that are using open source components to better understand how the components are being used, where they're being used, et cetera. So for those of you that aren't familiar with a software supply chain, it is a very simple concept to understand because software supply chains work like any other supply chain in any other manufacturing industry. You have suppliers. How many of you are part of an open source project? Right? Okay, you're part of the suppliers. You are building software for other people to use. When you build that software, you just don't say, hey, it's on my server sitting out there. You place it somewhere on the internet like one of these central warehouses like Maven Central or npmjs.org or rubygems.org or python.org. And one of these places is a central warehouse where developers worldwide can download and consume that into their manufacturing process or software development process and create finished goods from it, the software applications that we are all building as products or services for our customers. So these supply chains are very much in full effect operating globally. And for those that are developing the best software out there, they're understanding that not only are we operating with software supply chains, but if we take lessons from Deming that he was teaching at Toyota 40 or 50 years ago, right, that if we use the best quality parts from the best suppliers and we track and trace those over time, so if any go bad, we know where they are and we can recall them and fix those problems, right? Those lessons can be applied to software. Right? We're not just going to pick any project, right? We can pick the best ones. Do we need 5,000 parts, or do we need the best version of each of those parts to use within our software, right? Do we need 2,000 suppliers, right? So if you had 2,000 unique parts out of that 16 million, that's 2,000 parts. Well, how many of those are kind of similar to another one from another project? Do I need 4 or 5 different suppliers for a logging framework or web application framework or cryptology or whatever you would need? So you need to look at the best suppliers out there and then, as we said, track and trace over time. So let's talk about kind of the supply of components out there. We looked at, and we did this in last year's report as well, there's a site out there called modulecounts.com. All it does is it supplies a colorful chart like this, and it has different lines for different component types across all development languages, whether it's Go or Python or Ruby or Java, what have you. It says, here's how many different components are available for these ecosystems. And what we did by analyzing the data from their site about those components is we found out globally 1,000 new open source projects enter the market every day. 1,000 new suppliers are available to software developers worldwide every day. Of all the open source projects out there, we're estimating 10,000 new versions of components are released every single day. A massive number of suppliers, a massive number of parts. And when I looked at 380,000 open source projects that contribute to Maven Central, those organizations are releasing on average 14 new versions a year. So there is a massive supply that's available to you, and that's a good thing, right? Suppliers are out there building software, and they've figured out, just like you have, how do I make that better? How do I make that more feature-rich, higher performance, less buggy, fix a flaw, fix a security defect, what have you. So there's good reason for that behavior. Now, last year when I was here, we were talking about unimaginable numbers, right? And part of that is, how many download requests did we see from Maven Central last year, right? So last year we had just reached 17 billion. This past year we had reached 31 billion download requests. 31, like, I can't imagine that. I couldn't imagine 17 billion last year. I can't imagine 31 billion this year. There are 10 million Java developers on the planet, right? That number is not growing. It wasn't 5 million the year before and 10 million this year, right? It's pretty stable, right, in terms of the number of developers out there that are consuming these components. This is just tweeted by Laurie Voss. He's one of the guys that runs npmjs.org. So they're doing 52 billion package downloads a year. They are running at 1 billion NPM package downloads a week. So it's not just Java, JavaScript, NPM space. There is a massive amount of consumption happening out there. If you think your organization is using open source, right, you have been, you are in droves, right? When I was working with a company last week in the financial services space, they said, yeah, you know, we're working with Sonatype and we're helping this organization to do an audit of how much open source they were using across their application. They have an open source governance process because they're in the financial services space with all of our pertinent information. And they said, we have a process, a governance check that understands how many components we have in development, how many are used, and we have about 800 approved components, right? So that's pretty good. And when we did the audit and told them there were 13,000 open source components in their application portfolio, right? That's what the difference is between kind of guessing how many you have or forcing developers to go through a process to approve components that they will use. And when your process, like their process, was at minimum 2 weeks and usually 6 weeks and sometimes 9 weeks and one time 9 months to approve a component, right? Developers will find a workaround. Why? Because you're a pain in the butt, to say it nicely. If you are taking that long to approve a new component, you probably have 8 or 10 times more open source in your environment than you think you're governing. We need a more sophisticated way of thinking about how software is developed. And we need that not only, if you're a DevOps person, you need to think about how many parts and how many suppliers and how much variance and variation is there in my supply chain. Because we know Toyota in the Camry this year isn't using 27 different muffler suppliers, right? They have one and they have the best one, right? And because they've limited the variation and variability in their supply chain, they can better control the quality. If you're a security person, you need to understand this, and this is exactly the reason why I've done this report 2 years in a row and I'm working on the third one already, is because if you understand what's happening out there, you have to think about it differently. And if you think about it differently, you can come up with solutions. And my company has commercial solutions related to this space, but my company is not big enough to fix or improve this problem, right? There are others out there that have different commercial or free solutions. OWASP dependency check. Last year, 6.2% of the downloads from the central repository had a known vulnerability. And last year, 6.1% had a known vulnerability. That works out to about 1 in 15 or 1 in 16 components that are being downloaded that had a known vulnerability from day one. We can't remove the components with known vulnerabilities from the repository. If any of you out there remember, who remembers NPM Gate? It was like when was that? It wasn't February, it was May-ish, right? Yeah, some developer was being threatened to be sued because his component was called Kik, and the Kik organization wanted to sue him for using that name within a component which he had a long time ago. So he removed the component from npmjs.org, and like 10,000 builds broke within 30 minutes, and there was chaos there, and it wasn't an immutable repository, and builds were breaking, so they put back a part that they believed to be that missing part. You can't, if you want to fix a bad piece or a bad component that you have, you need the old or original components to recreate your application and then replace it with the good one. And just because the part is bad for you doesn't mean it's bad for you, and we don't know the use case scenario. So we can't remove the bad ones, but there can be ways like dependency check to tell people what's a good one. So within these downloads that we saw, no one here is downloading billions of components in their organization. So the average downloads that I saw across these 3,000 organizations were about 229,000 components overall. Just like that organization that's downloading 16 million, there are about 5,000 unique parts within that, and about 2,000 if you strip out all the different versions. So the number of parts is 5,000, the number of suppliers is about 2,000 that you want to, or you're managing through your infrastructure. So one of the things that we also saw was within this population of development organizations, about 7.5% of what they were downloading, so that's like 1 in 15, 1 in 14, so one do the math. But that's a lot, right? No high-speed development or manufacturing operation globally operates with a defect rate like this at high velocity. And the higher velocity that you move at and want to maintain quality, of which security is only one aspect, is a challenge that we can fix with the proper approaches. So just because a software component, and we had this discussion last year as well, just because a software component is downloaded does not mean that you used it, right? Sure, I downloaded it. I was testing out the design of some part of the application I'm building, right? It was a snapshot build. I don't know what version exactly I was using, right? So that version of that component was downloaded, but what we were able to do this year was we looked not only at the downloads with 6.1% vulnerable, we looked at about 3,000 repository managers. These are where some development teams keep their components locally, where they don't house them or they don't rely on the central repositories fully, but the local repository managers that house these, and about 5.5% of those had a known vulnerability in them. When we looked across 25,000 applications that were using open source components within them, we found that 6.8% of the components across all of those applications had a known security vulnerability in them. So what that tells me is that software components that are entering the front of the supply chain are flowing through the supply chain into the finished applications. That if you have vetting processes in place, they are not catching enough of what's happening out there. and maybe certainly if they're manual, they are not keeping pace with the volume that is being consumed out there. That organization with 16 million downloads, they employ one person who looks at open source components and approves them, and only for licenses. They have no one employed that checks security vulnerabilities in those components. It's just not part of it. License risk is a higher risk for them than security risk. Imagine that. Who's seen this this tweet from I Am Developer? This is like one of my favorite. Right? So this is my tweet. So about 106 open source components are used in the application, right? And what we saw last year was that amounts in the percentage of components, that amounts to about 7 of those have at least one known security defect in them. But when you're consuming thousands of components across your applications within an enterprise, right, looks fine. Dude, I have a deadline, right? I know that's there. I was talking to someone last night, their company that builds software in the financial services industry. And that person said, yes, I know we have vulnerable components in the code, right? But I have a deadline, so I'm just waiving that, that Jira ticket, right? And that, they go to release the software again, still has the vulnerability in it. They flag it, now it's waived again, right? They flag it again, they waive it again, right? I've got a deadline to meet. I know there's a vulnerability in it. I don't have time to fix it, right? And then we're wondering why we're being breached along the way. So here's some of the cool stuff that, how many of you know Bruce Mayhew, works on WebGoat? Right. Bruce, you should know Bruce. Bruce is a really brilliant guy. Comes into my office 6 months ago, and he's like, Derek, I've got this amazing data. And he spends like an hour and a half explaining it to me. I'm like, I don't get it. So, but thanks for sharing that. And the next day I'm like, I've got it. Here's what Bruce was telling me from the analysis of 25,000 applications, was that of all the components used in the applications, the blue line is showing me what is the average age of a component across those applications. So 1-year-old components make up about 18% of the apps. 2-year-old components are just over 20%. 7-year-old components are about 5% of those used across these applications. And then we did a look at security vulnerabilities in those. So 1 to 3-year-old components have just under 5% of those components have a known vulnerability. But if you're at 8, 9, 10 years old, you're almost at 15% of those have a known security vulnerability. So when we're talking about use the best versions of parts from the best suppliers, component age matters, right? So the number of components that are over 4 years old in the applications is like 67% of components. You're using component parts that are 4+ years old, in some cases 9 and 10 years old, when there are newer versions, more functional, better performing components out there that you could use in your applications. And if you move people toward use not the newest, but one of the more latest, like in the last 3 years, latest components, then the number of security defects across your population, your security debt, will decrease substantially if you can put in a practice that says, in governance, we're just going to tell you, use components that are 3 years old or younger, right? Simple governance. You could have nothing to do with security in that security focus in that governance policy. It's just use newer components for developers that don't care about security, but you can reduce your security debt substantially. I'll give everyone the slides afterwards. I'll tell you how to get them quickly. The other thing in here, so when we looked at these applications in terms of using newer versions of components, in this analysis is what also Bruce came to me with and said, out of all these applications, the number of components that are on the latest version, 1-year-old components, about 13% are on the latest version. 5-year-old components, 14% are on their latest version. 9-year-old components, 20% are on their latest version. Okay, quick translation of what this means. 9-year-old components, 20% are on the latest version. You're using a piece of software that someone developed 9 years ago. It has never released a newer version. That is either a perfect piece of software that was so good, right, in 2007, right? Yes, sorry. So 2007, someone developed that perfect piece of software, or this is a project where someone developed a cool piece of software that may still be in use, widely in use, right? But no newer version has been developed or released in that. And those are the versions that have 3 times more security defects than the younger versions. So you have older versions that are non-supported, and if you want to remove that, there is a higher chance that there is no alternative newer version of that non-secure component available to you. So again, using new components is important to have within the portfolio. Yeah. Yes, older components are used in older applications, but of these 25,000 that we are analyzing, they are actively under development, right? So if it was we scanned the portfolio of JPMC, which has applications, just to name a company, applications dating back to the 80s, right, that didn't even have open source components in them. Yes, that would be a good argument. When we're looking at active development going on, usually involving continuous delivery, continuous integration platforms where they're doing higher speed development, it makes less sense. The argument is true. There are older applications with older parts. There are components that have dependencies that are older dependencies that have never been updated, right? But again, making the invisible visible, the more we're aware of this, the more we can start to think, how do we need to approach this problem, and what are the ways that we can go about resolving it? Yes?
I just want to clarify, you're not claiming that newer components have less vulnerabilities, just less known vulnerabilities, is that right?
That is true. They have less known vulnerabilities because they haven't been discovered yet. We often say software ages like milk, not wine, right? So the longer it's out there, the more popular it gets, the more folks like you start to look at, hey, I wonder what's in this code. I wonder if there is a vulnerability, and aha, I've discovered something. So that's a natural progression of what we've seen, right? But if you want to have stronger fortification of your applications in your portfolio, keeping up to date with the newer components will help you just by the percentages. So someone that I was talking to earlier out there when I was doing my slides, I said I would bring up Apple. And everyone, I think it was February of this year, it seems longer than that ago, Apple and the FBI were kind of going at it, right? And they were going at it because Apple had placed very strong encryption technology into the iPhone, right? And the FBI wanted in, and you can fall on either side of the argument on whether you should be allowed, to break that encryption or not. But part of what I saw within my research when this was going on, I contacted our data team and I said, there's a component called Bouncy Castle. Everyone knows, right? Crypto, right? So I want secure communication capabilities inside this part of my application. So I'm going to use Bouncy Castle. And Bouncy Castle is incredibly popular, right? So last year in 2015, there were 17.3 million component downloads of Bouncy Castle from Maven Central. 17.3 million, there's only 10 million Java developers on the planet. It's popular, right? I mean, yeah, just by the math, it's popular. Okay, so of those, right, Bouncy Castle, let me say, is an excellent open source project. And supplier quality ranks very high. When they have a problem and a known security vulnerability is discovered in it, this project fixes their component and releases a fix, a newer version of the component that fixes that vulnerability quickly, right? So 5.8 million, 33% of the component downloads last year were the known vulnerable versions of Bouncy Castle. There are perfectly sound versions available, perfectly good versions available, yet 1/3 of the downloads were known vulnerable. 13,000 organizations that needed encryption within their applications voluntarily elected to download the known vulnerable ones. Now, they might not know if they didn't go through and check, hey, does this encryption actually work? So when people were complaining about one organization having strong encryption, I'm seeing 13,000 organizations across 74 countries that just downloaded whatever they wanted, right? That's crazy. So Commons collection vulnerability. Everyone's heard of the Commons collection vulnerability, right? So where open source and stealing a line from Josh Corman are the titles of his presentations, where bits and bytes meet flesh and blood, right? Hollywood Presbyterian Hospital, right? That's what this is a picture of, right? Who knows why that hospital is important? Everyone should know that, right? This is ransomware, right? Right? And how did they get in, right? JBoss has a Commons collection known vulnerability in it, and they were able to exploit that infrastructure and take control of that hospital's infrastructure where patients could not be provided care and had to be moved to another hospital because the systems were locked down, right? So when we look at, is it important, and do we need to know not only are we using strong encryption, but are the systems that we rely on for our health and safety and other things using these components that are known to be vulnerable, that are leaving us prone to attack. So I almost didn't include this slide, even though I love Forrester, but I also, we're videotaping, so anyway, Forrester said something very positive. Governance processes that depend on manual inspection are guaranteed to fail. And part of why they said this in a DevOps report that is coming out, this is not released, but it's coming out tomorrow or Monday, is that they understand this huge volume of consumption is happening, right? And we still have outdated security practices that are relying on manual reviews of these components that are not keeping pace with the volume of consumption and the need for speed and the need to be competitive out there in the market. So one of the cool things that happened between last year and this year, right? Last year we were talking about OWASP and the top 10 and FSISEC. They have guidelines for their members or the top 10 list that say don't use components with known vulnerabilities. But the traction around that concept was gained significantly over the last year, where we saw evidence through the Department of Defense, the Department of Energy, the American Bankers Association, 18F, private organizations like Exxon, Mobile Clinic, Underwriters Laboratory, CyberSeal programs, right? These are all documented within the report, where these organizations are saying, we understand how software is being developed today, that is being manufactured, not written from scratch. And because of that, right, we want to know if we're going to purchase software, if we're building software, we want a manifest. what software components are in this application. We also want to know if any of those components have a known vulnerability. We want you to fix it before we buy that software, right? Or before we ship it, we want it to be fixed. And if a known vulnerability is discovered, we want you to fix that in the, if it's discovered in the future, we want you to fix that in a reasonable amount of time. So these organizations are coming out with policies and guidelines and rules within their own organization about how software is developed and how we can protect our own organizations. And the American Bankers Association guidelines were very interesting because not only was it focused on this kind of procurement trio, right, but it was aimed at CIOs and CISOs saying, if you follow these guidelines, your cyber insurance risk premiums will go down. That's why you should follow these guidelines. The economic value of following these practices benefits your organization. Josh Corman had worked to build this. I think it's still available at sonotype.com/calculator. But we looked at what is the cost of how to of remediating components across an application portfolio. If an organization had 2,000 applications, and you looked at the number of vulnerable components across that portfolio of applications, and you wanted to remediate you couldn't remediate, and this will be true for most any organization out there, you won't be able to remediate every known vulnerability in every component that you're using. There are literally just too many. Right? So if you're going to start anywhere, you just have to start with the worst ones. Pick the CVS S10 known vulnerabilities within the components and fix those. If you fix 10% of them, it would cost you about $7 million. That is stealing from your innovation budget. Right? So developers want to be more productive. You want to be more secure, but there is a cost to it if you don't build quality in from the beginning. And to build quality in from the beginning, you can use gold standard parts, right? Using the best parts from the best suppliers. And the only way to go about that is to automate. If you are not approaching this with automation, you cannot keep pace. The volume is too high. And that's the one kind of overriding theme that comes out of last year's research and this year's research. The volume is too high to keep up with. You don't know how much is coming in the front door, the back door, and the side windows into your organization. If you have a manual how many of you have an open source governance process rules within your organization? Right? There are rules somewhere. There's guidance. No. Like, really raise your hands. Like, you have, okay, like a third of the room, you have rules, right? How many of those are those are paper-based rules, right? How many of those are you following, right? When I did the survey, I need to do the survey again, but it was almost 3 years ago now. We asked 3,000 developers, do you have an open source governance program? And I think it was 50% or so, 47% said yes, 57% said yes, and then we asked, do you follow it? And only 68% of those followed it, right? Because it was too cumbersome to keep pace with the volume that they were consuming at. So I'm going to give you an image of what some of this looks like, of what automation looks like to tell you what's out there. There are, everyone from Sonotype to OWASP Dependency Check to Veracode to HP to, I'm sure, a number of other organizations you've heard of that help you understand what open source components are being used in your infrastructure so that you can make better decisions. But part of this, when you look at how to help developers, if I am a developer and I pick this version of this component, and of course we pick a bad one, Struts Core. If you're using Struts, stop. This version of Struts has known vulnerabilities to it. What I can tell a developer inside their IDE at design time, almost the earliest point in the development lifecycle, is this component has known vulnerabilities. Here's every version, every column of this shows every version of the component that's available and are any of these safer to use than the one I'm going to select? Do any of these meet my policy so that I can safely use that version of that component and avoid the vulnerabilities from the start? Gartner just produced a report back in September to take this even earlier than the IDE, that they say you should use, organizations as a best practice should use what they call an OSS firewall, right? Which is basically when you're downloading a component from any public repository, evaluate it before it's allowed in the front door, right? The OSS firewall basically does that evaluation ahead of the downloads or at the time of download. So a developer designing an application cannot pull in a known vulnerable piece of software. We can't remove it from the repository, but you can guard it from getting into your organization by quarantining those known vulnerabilities and examining them. And yes, that will break the design or break the build, right? But there are clear reasons why that might be appropriate. Certainly at a high level, because those policies wouldn't understand the use case for, well, what is that component being used for and where. You can build these kind of policies into things like Jenkins and Bamboo and Hudson and TeamCity and whatever continuous integration platforms that you're using. So upon every build, within seconds for every build, you can evaluate every component in that build and have a manifest built of all the components and check those against policies, whether it's security or licenses or age of the components or whatever your policy might be. You can create, who has created a software bill of materials? Anyone used OAuth dependency check? I mean, that's basically what it does, right? If you haven't, just go out and it's free. Go out and try it to evaluate it, to analyze an application. There's a link up here in the slides that I'll provide you. We have a free tool that does it as well. It takes about, I scanned Jenkins, I scanned our Nexus repository open source product. It takes 10, 15 seconds to produce a bill of materials. It's pretty simple, it's pretty fast. You'll be amazed at what you see. If you don't want to pick your own application, pick your favorite open source application and put it through the analysis to see what comes up. I'm going to skip through these. So the State of the Software Supply Chain report, just like last year. If you want the slides and if you want the report, I'm making it very easy. My out-of-office email settings are on. The links to the presentation and the links to the report are in them. Anytime today, if you email weeks@sonotype.com, you don't need to say thank you, whatever about the presentation. Just email me. The out-of-office will come. You'll see the links. They're posted on SlideShare. So they're publicly available for you to download and share or read within your own organization. So definitely do that. The other thing that I will point out, and this is a self-promotion for a conference that you may or may not have heard of. A number of us, including Ernest and Karthik and James Wickett and Shannon Leitz and myself and a couple of others are running the All-Day DevOps Conference. It's November 15th. It is online. You don't have to travel. Within that conference, we have 57 sessions in total. 18 of those are automated security-specific DevOps tracks. It is practitioner-led discussions, no vendor talks. It is live online. It is all recorded. So if you can't attend for 15 hours that we're stretching that conference that day, you can log in anytime and watch these sessions on YouTube. Yeah, so the question is, if you're buying open source applications, or you're getting open source applications and then you're buying support, is that better for you? Yes, because one, if you analyze that application, if you run a software bill of materials for it and you see there are known security vulnerabilities, you can go to that organization and say, hey, I'm paying for support, and by the way, I'm a security professional, and by the way, you have known vulnerable components in this, and would you fix them? Right? If you don't have support, you can still make the same request. It just, you might have more ears depending on how much you're paying them. But an open source application has no more or less number of open source components than closed source. And even, proprietary software has just as many components in it. So I need to wrap up, but I'll be here all day.
So help me saying thank you.
Thank you.